Hi guys, ArchiTracer is a code coverage tool for 10 programming languages. It supports all build environments, compilers and cross compilers independent of the target architecture without any limitations. In this video, we're going to learn how to generate code coverage using ArchiTracer code coverage tool for file system in the 64-bit Linux kernel. It uses 64-bit architecture with the internal Linaro compiler, and this is how at the high level the architecture looks like. I mean the testing environment looks like. So this is the Linux kernel. We have different parts of the Linux kernel along with this drivers, and we have the host target. Once we have the kernel image, we are going to test it on target board or on the emulator. Then we are going to get the test results here, and with ArchiTracer tool, so this is how it looks like. And the first step is or we can say that it's a one-time job where we are going to add the ArchiTracer runtime library file to the kernel. So it's a very easy one-time job. And then let's say like I want to instrument this file system, so to generate the code coverage, then we need to go ahead and instrument this. So we need to go to this make file of this file system module or the part of this kernel, and add the ArchiTracer append the ArchiTracer option. Then just get the instrumented kernel image, test it on the target. Then the code coverage will be stored in the rkmm file, so that we can copy this. So basically this rkmm.ko file is going to help us to get the code coverage from the memory. Basically the code coverage is already in the memory, so this file is going to help us to get the code coverage out of the memory, and then we need to copy it to the host, then generate the code coverage. So when we instrument this file in the project working directory, this intermediate files will be generated, and this is where we need to have this code coverage file and generate the report. So this is one-time job. So it's a three-step process: instrument, get the code coverage from the target, and generate the report. So we'll see like how to do it in the live demo. So this is the emulator, 64-bit ARM architecture, 64-bit architecture emulator that we have. So the first step is that we go ahead and add the ArchiTracer runtime library patch. So what we need to do is we need to go to the make, do the make, or we can manually add this make menu config, and it's going to pop up a interface. So I need to go to this kernel, and then go to the custom kernel, select the custom kernel patch, and here I need to give the path of the patch that is present in the ArchiTracer installation folder. So this is the ArchiTracer installation folder. Just give that path, press enter. So save it, and you can also manually add it to the configuration file if at all it's required. Then what we need to do is, since we are instrumenting this file system, let's go ahead and make one more change. Let us enable the patch what we added. Okay, we can also manually add it to the configuration if you're comfortable with that. Go with this. So it's going to take a couple of seconds to bring up this menu. So once it is there, then what we need to do is we need to make sure that ArchiTracer related patch is enabled in the library module. Okay. Then what we need to do is go to the end of this and library routines, and you can see that since we added the patch there, so it's automatically enabled here. And since we are instrumenting the module, so probably we will add around, like, it depends, we can also get exact number. What is the number that you need to add it here? Let's make it as 40,000 counters, and then save this. So these are the two things, only these things you need to enable. Then exit, Okay, so since we enabled it, this is a one-time job. Like what we did is a one-time job. Then what we need to do is go back, and what we are going to do is we're going to instrument this file system here. Okay, so go to this output, build, and we have this Linux, and go to the FS, and let's sort it by type, and here we will select ext4, and go to the make file. So it's best to add it manually instead of going and automating this process if whenever you want to generate the report. So this is the only manual step, I guess. If you have a backup of make file, you can add that. So all we are doing is we are appending this arctracer option with -r. Okay, and whenever you want to generate the report, just close this, and this is the first step that I was talking about. Then what I need to do is come back here and go ahead and build the project, something like -j4. I'll make 4 because this is the virtual machine. And then what I need to do is I need to go ahead and okay, press enter. So depending on the system resources, it's going to take some time, and only the files that are related to the file system will get instrumented because we added. And also, if you want to instrument the entire module, if you have sufficient space, then what you can do is you can go ahead and instrument the entire module, and you should be able to see some green, this one where it is getting instrumented. I think it is running in parallel mode. Okay, you can see that some of the files are getting instrumented. These are related to the file system. Okay, it's pretty fast. You can see that even this is getting instrumented here. Okay, let me go ahead and press. Okay, you can see that some of the files are getting instrumented, and we need to wait for a couple of more seconds. So building of this one, it's not related to the arctracer tool. So it depends on the system resources that we have while we build the project. Okay, so it's almost done. Okay, it's done. Now the instrumentation is done, and now what we need to do is we need to go ahead and load the start the kernel module. So what we need to do is we need to go ahead and execute. Give me a minute. So let me go ahead and execute this. So okay, so this is going to bring up the Qemu Emulator. Okay, so I'm going to log in as root user, and then I need to run the unit test suite related to the file system. So I'll go to the user lib ld ldp test suite and go here, and then what I can do is I can ls. So we have this test suite here, so go ahead and run this and this is a file system, okay, that we're going to run. So now we can see that all the test cases related to the file system are getting executed. So it's going to take a couple of minutes, I guess, to complete running the test cases. So I'm going to just pause this for some seconds. Okay, so it's completed. Now what we need to do is we have the code coverage in the memory, but we need to get that code coverage. So the first thing is let me go ahead and load this arc-tracer patch. That's going to help us to get the code coverage. Okay, and come back to the root, and then what I'm going to do is I'm going to get that code coverage from that library. Okay, now I can say that ls -a. Okay, let me do this. Okay, so already it has been existing here. Then if I do this, let's okay, now we have that. Actually I executed the wrong command. Okay, now since we have the code coverage in the emulator, now all I need to do is copy to the host machine. Okay, just so what I'm doing is I'm giving the user name and the IP address along with the working directory. So it says that you want to execute, yes, rk validate. Okay, so it has copied. Now to generate the report, just go ahead and minimize this, and you can see that it has copied to the build directory. So go to build directory and output, and we have this within the build, and you can also have it in the custom path if you want. So this is the basically this is the build directory where that you can see that this file is generated here, and you can see the time and when it was generated. Okay, now even this this is the arc-tracer instrumented files. Okay, so if you want to see like how many how much, what is the count here that needs to store the code coverage, just go for this tsv file and go to the end of this. Okay, and you can see that this is the amount that we need. Okay, it depends on number of files that we are instrumenting. Then what I need to do is I need to just open the terminal, or like if you have automated this process, just execute the command rk results. So before I run this, okay, let me go to this arc-tracer folder. You can see that there is no report here. So if the moment I press enter, so it's going to search this and convert all the related files here and generate the intermediate file. So this is showing the output, like what are the counters and everything. So now you can see that it has generated the report, arc-tracer report. So on the left hand side we have a tray view, on the right hand side we have this two tables. The table on the top is a code coverage for the project. It remains the same, and this gives us total number of source files, functions, what is the project name, when it was instrumented, report generated, and what is the root directory, stuff like that. And you can also see that for example, let's say like I'll go here. If I select this, you can see that it based on this file it's showing the code coverage. Okay, and if you want to get the function summary, just right click on that and you just hover over this and you should be able to see the function summary. If you want to go to that file, just click function, just click on this, and if you go to that function, we can go there. And also if you just hover over this, you should be able to see the code coverage. Just click on this and it will take you to that function. So this is the function that we are talking about.